Hello, good morning, everyone. Hi, guys. Am I audible? Is my voice reaching to all? Can I get the responses? Is my voice reaching to all? Okay. Hi, Rajesh. Good morning. Hi, Mohan. All right, guys. So we'll start the class in 2 minutes. 2 minutes. Okay. Okay. All right. So I'll just share my screen here. Fine. So we are discussing the Synapse Analytics workspace concept, wherein we have seen many things till now in Synapse Analytics. Okay, like deployment of Synapse Workspace, okay, dedicated SQL pool, serverless SQL pool, executing the queries, generating the data, okay, and analyzing the data in the graphs, different types of chats we have seen, okay, different queries we have modified, and we have done the data visualization. Many things we have done. So the same continuation with the same. Okay, what we'll do today, we'll analyze the data with serverless Spark pool. Okay, with serverless Spark pool in Synapse Analytics. Okay, and steps on a very high level. First, okay, we'll create a serverless Apache Spark pool. Okay, then we'll understand serverless Apache Spark pool is what, and all. Then we'll analyze the enterprise New York City taxi data with a Spark pool. Okay, we'll load this data into Spark New York City taxi database that we are going to create, and then we'll do the analysis using Spark, that is Python scripting, using Python scripting in a notebook, same like how we have done in the Databricks clusters. Okay, we have created the notebooks, and there we have generated the cells, and we have written the Python scripts to do the data visualization. Same way also here we are doing the generating the notebooks in Synapse workspace, and then we are going to do the visualization of the data for different scenarios and all. Fine. So we are going to do this this time today. We are going to do that using Spark pool. Okay. So we'll create a Synapse Analytics. Okay. So first step is create a Synapse Analytics. I'll come here to Azure portal. Okay. This is Azure Synapse Analytics. I'll click on create here. Okay. I'll take this resource group and say here Azure Synapse Analytics manage resource group. Okay. Naresh. Okay. Azure Synapse Analytics Workspace. Okay. Azure Synapse. Okay. Workspace. And this is Azure Synapse Analytics Manage Resource Group. I'm just giving the names in the short form. I'll create a storage account. This is going to be Data Lake Gen 2 storage. So I'll say here 1879. Okay, Naresh say Okay, and then I will say here, I'll say NFS. I'll say here Gareth. Same. This we have done many times, the deployment of the Synapse Analytics workspace. That is the same thing we are doing here. Okay. Go ahead and we'll deploy the Synapse workspace on create. Then we'll launch the Synapse Studios. Okay, we'll launch the Synapse Studios. Then we click on data icon. Okay, linked. Click on the container. Okay, just we'll do all these steps one by one. Just hold on. Step 2. This is step 3. This is the PySpark. Okay, we are writing to do the data visualization. Step 4. Step 5. See here we are writing this data in the notebooks, in the notebook, like how we have done in our Databricks cluster. The same way we are doing here also. Okay. Okay, let the deployment gets completed here. Okay, hopefully it will get deployed successfully. Okay, so many other resources, SQL database, okay, SQL instance, many other things will also get deployed along with the Synapse workspace. Okay, it's a very, very expensive service, guys. Don't try to do this in your paid subscription. You will get very high bill. So try to do this in your free trials only. It will definitely get created in your free trial, no doubt. Fine. Now I'll go here to the workspace and I launch the workspace. Okay, I'll launch the studios. Synapse Studios. Okay, what it is saying next, click on data icon. Click on data icon, then linked. So this is the data icon. Click on this link here, and here we are having container that what we have created, NFS. Okay, this created while creating the Synapse Analytics plus new folder, give name as data. Okay, so if you come here, this is the container we have created inside the storage account. Okay, just hold on, it is loading. Okay, this is the container we have created. Okay, and it is asking us to create a new folder. We will give the name as data. Any name you can give, nothing as such. So I'll just say here new folder data, which is name data. Okay, create, double click on data folder, upload. Okay, go inside this folder here. Then we have to upload the file. Click on folder icon here, we'll navigate to our local laptop to upload the file. This file we have to upload. Okay, so I'll just come here, say folder, take this one, say here upload. Okay, done. Then what is Apache Spark here? Apache Spark is a parallel processing framework. Okay, it's a parallel processing framework that supports in-memory processing to boost the performance of a big data analytics application. To boost the performance of a big data analytics application. Okay, we can create serverless Spark pool under management hub menu in the Synapse Studios. Spark is a framework. Okay, what is Spark here? Is a framework which can be used for big data processing. Suppose if we are having big data, huge volume of data, and if you want to perform same, see almost the same concept we have read when we want to process the data, which is in a huge volume and all, then Databricks will be the best option compared to ADF. In the same way, here also, when we are having huge data, and if you want to perform the analytics on top of this, then we can go with the Spark technologies. We can go with the Spark technologies. And here in Spark technology, we're having cluster concepts. Okay, we are having cluster concepts, and what will happen with these clusters? Basically, these clusters will help us to execute our high volume data queries, and it will give us the good performance, and it will makes us easy to do the data visualization also as per our requirements and as per our project needs. Okay, and here in this Spark we'll write the code in Python, Scala, okay, R, SQL, etc., etc. This is same like Databricks what we are going to do, but the look and feel is little bit different here. Okay, fine guys. Okay, no, Spark is the Spark is the framework, and Python is the scripting language. So when we are writing this in Synapse Workspace, okay, as it is having the Spark framework, that's why we are calling it as PySpark. We are calling it as PySpark. Okay, is that clear, Rajesh? Fine. In Azure Databricks, we have created Spark cluster. Yes, correct. What I'm saying, in Databricks, we have created the Spark clusters, and this cluster is running on our notebook cells. But when it comes to Synapse Analytics, here we are creating Spark pool, and this will execute our notebook, and this notebooks contains our code or logic that we are going to write. And here in Spark pool, we can define how many nodes we want, what is the size of the node, etc., etc. Same like Databricks. Databricks also, when we are creating the clusters, we have defined the node sizes, node requirements, how many nodes we want, single node, multiple node, what node configuration we want, all that stuff, right? In the same way here also it is saying the same thing. Okay, Spark pools or SQL serverless pool will charge only based upon the usage. Okay, so Spark pool is the one which is going to execute our queries inside the Synapse workspace and inside the Synapse framework. Okay, so it is saying that it will charge only based upon the usage. Okay, so how we are going to create a Spark pool here? See, click on Manage in Synapse Analytics Studios. Click on Apache Spark. So I'll just come here to Manage. Okay, I'll say here Apache Spark pool. Okay, then I'll say click on Apache Spark pools plus new and fill the details as shown below. So Apache Spark pool plus new, and see, this is what the Spark pool we are going to create. Apache Spark pool we are going to create. Okay, Apache Spark pool name, you can give any name. I'm giving it as Spark 1. Okay, I'm giving the name as Spark 1. Okay, node size family, memory optimize. Okay, we are having isolated compute as disable or enable. Okay, isolated compute means the compute, the node which we are going to use for this Apache Spark pool. It is we have want it to be keep as an isolated. We can say here enable, or else we can say here disable. I'm just going for disable here because we are just creating this Spark pool for trial and running purpose. Node size family. It is offering two types of node families: memory optimized and hardware accelerated. I'll go for memory optimized. And what is the node size you want? Same like Databricks, 32 GB, 64 GB, 4 virtual core, 32 GB RAM, 4 virtual processor. Okay, 64, 8 virtual core, 128 GB RAM, 16 virtual core, depends upon whatever you want, you can choose. It is giving you some 5-6 options. I'll take this one. And the higher you take, the higher would be the charges for you. Okay, fine. And then auto scale. Okay, suppose for an example, if this Spark pool needs more power, more compute and more processing, more virtual power, then if you say here auto scale enable, then it will automatically increase the node sizes. Auto enable, this also same option we have seen in our Databricks clusters. If you guys have done the practice, you can easily catch up. Okay, so node size range we are passing here. How much we are going to pass? 3 and 3 means minimum nodes is 3, maximum nodes is 3. Minimum is 3, maximum 5. So initially the Spark pool will get created with 3 nodes, and I believe it is taking minimum 3, not less than 3. That is a standard. If you want to go with 2 nodes, see, it will not accept. It will change to 3 automatically. See, it is changing to 3 by itself. See, it is changing to 3 by itself. So minimum is 3, maximum you can define based upon your need. Oh my god, see, up to 200 nodes it is going to create, which is very high. Okay, and the bill is also very dangerous. So I'll just say here, okay, 3 to 5 also is fine. No, I'll go 3 to 3 only, else it will get fail, because for free trial it might be trouble. I'm just going with 3 to 3 only. Okay, estimated price, it is saying that 137 rupees per hour. If you change here 5, the price will get changed. Okay, if you say here 10, minimum 3 and 5, then the price will get changed accordingly as per the configuration how you are doing. Okay, this is what the node size. We have defined number of nodes, set minimum and maximum 3. Less than 3 it will not accept. Okay, I have mentioned here very clearly. Finally click on review plus create, and then click on create here. Okay, so next, additional settings. Okay, this is the frameworks, as this is going to support you to write the languages, multiple languages here. So different languages, frameworks, it is being considered here. Just a number of minutes ideal. I'll just say here, if it is ideal for 20 minutes, then stop my Spark pool, something like this. Automatic pausing, yes. Enable means yes. Automatically stop the Spark pool so that I can save some money. Same we have seen in Databricks clusters deployment also. Okay, these are the different languages, frameworks it is taking. I'll just leave. Here we are not having any option to change. to upgrade the languages for Python, Scala, Java, Delta Lake, and R programming. Okay, but here we are having few, like multiple frameworks we are having for Apache Spark 3.3 version, 3.4 version, 3.2. I'll just go with 3.3 only, default one. Okay, Apache Spark configuration. Okay, I'm not touching this one. View configuration, multiple configurations might be, we are having it here. Okay, I'm just going with the default value. Okay, intelligent cache sizes, it is taking 50%. Okay, allow session level packages that configure setting release to package and how they can. These are all internal things, guys, for your Spark pool. I just keep it as it is. Next tags, pass on the tags here. Next, say review plus create. Tags is optional. Always it will come, and then you can pass it accordingly, or you can leave it also. Then go for the Apache Spark pool provisioning. Okay, don't go beyond 3.3, guys, because we are doing it in a free trial. So free trial will not support multiple nodes like 10 or 15 to 20, something like this. Then it will get failed miserably. So 3.3 is fine, because anyhow we are going to execute medium small level scripts only, not very high volume of data. Fine. So once I click on create here, okay, then the Spark pool will get created, and df is what? It's basically a variable we define. This is like a variable virtual table. This is like a virtual table that we are going to write our in our Python script, and this table carries schemes, columns, data types, etc. Okay, now click on develop icon, left side only. So successfully deployed. See, successfully deployed the Spark one. This is Apache Spark pool that we have deployed inside our Synapse Analytics workspace. Now, what it is saying, step 3, click on develop icon. Okay, so here is your develop icon. Okay, click on plus notebook. See, now here also we are getting the notebook. See, click on plus and click on notebook here. Okay, I'll say here my practice notebook. Okay, my practice notebook 1. Okay, fine. And then next, what it is saying, attach to Spark 1. The Spark pool what we have created, that we have to attach to Spark 1. Okay, we have attached to Spark 1. This is the Spark pool we have created in above steps. Languages, PySpark. That is basically Python. So where we can select the language here, see, here is the option. Multiple languages it is supporting. Same like our Databricks clusters notebook. Spark is there, Spark R. This is SQL, this is R programming, this is Scala, and this is Python. So I'll select here Python. That is what I'm showing you, Spark Python. You can choose any language as per the project requirement. Now we'll write the code in the notebook to load the data of this file into this virtual table. Okay, this is the code we are writing. Then do the publish, then run this cell. Just click beside the cell, run button to run the cell. Wait for some 6 to 8 minutes for the result or output. So what I'll do here, okay, I think I have to change this path. Okay, so here if you see, this is the magical command, same we have seen for Databricks clusters notebook. Fine. Then we are defining a virtual table. We are using this Spark method, and this is our storage account name. Okay, and in this folder container which we have created data, we are okay loading the file. Okay, this file na, with that we have uploaded inside the container. If you come here, if you come to home, if you go to the storage accounts, see, this is what we have created a container, and we have uploaded the file. See, data, this one, data folder. This is what the same thing we are writing here. So I'll take here, paste it. Now see here, illustration of above code. This code I'm explaining here. This is magical command, obviously. df, this is what? This is the path that we can get from Parquet file. Go to another tab, right click the Parquet file, properties, copy abfss path and paste it in the code as shown above. So this is our file, right click, properties, okay, abfss path, copy this one, close, come here and paste it. Okay, we are changing the storage account name that what we have created in this lab for this class. This is the container with the name we have created data, and this is the file we have uploaded. That is what I am showing it here. Okay, storage account, container, file. That is all we have mentioned in the path for the file. Okay, next format equal to Parquet. Okay, our file is in Parquet format. That's why we are writing Parquet here. Okay, fine. This one format equal to Parquet in our code. The same we have written here. Okay, then next display. This is the method. This is the method, display method we use always to populate the data, to display the data. And this is the virtual table in which we have assigned the complete file data value here. See, this complete value of this file we are assigning to this df virtual table. And I'm saying limit to only 10 records. Show me only 10 records. If you say here 20 records, it will show you 20. If you mention here 100, it will show you 100 here. Okay, I'll go with 10 records only. If there are 100, 200, 5,000 records, then the query will take long time to get executed. That's why in order to show you the result set output, I'm just limiting it to 10, 5, 20. Yet you can set whatever you want. Fine, this is done. Then what we'll do here, we'll do the publish, and then we'll run this cell. First, I'll do the publish here. Then run the cell. Just click beside the cell run button to run the cell. Wait for some 6 to 8 minutes for the result set output. Okay, I'll say here this one, run cell. Okay, run cell. Okay, this is your cell. This is your notebook. This complete is your notebook. And first time when you are running, it will take some 8 to 10 minutes because the cluster has to start. The cluster has to start, and the underlying resources that what has been created all will get started. So that's why it will take huge time for the first time. Okay, then slowly it will give you the good performances as you keep on executing the different queries here inside your notebook. So this is my notebook, my practice notebook one. This is my cell. Okay, so wait for some 6 to 8 minutes, 6 to 8 minutes for the result set or output. Okay, so let the result set comes here, output comes here. Okay, it will take sufficient time, guys. See, 1 minute 46 second, 48 second has been completed. because the cluster has to start, the engine, the complete engine, the internal algorithm, every part will get start here. See, example, something like, you have done the detailed service of your bike, and when after the complete engine has been done for your bike repair, then when you start the bike first time, it will take some time, right? Something like this it is. And for the first time, it will take a huge time. Then second time, third time, fourth time, it will give you the results very quickly, gives you the best performance. Anyhow, we have taken three nodes only. Okay, depends upon the project requirement. You can set here 5 nodes, 10 nodes, depends upon. But everything is happening here in the PySpark only. Okay. As per Microsoft documentation, they have mentioned here how much time. 8 minutes, maximum 8 minutes. Okay, 3 minutes has been completed, almost 4 minutes. Spark is a language. Python is a language. Okay, Python is a language. When you are writing these languages, okay, in your framework, either you take it's a Databricks or Synapse workspace, then we are calling it as PySpark. Okay. See, you cannot write this language in a notebook, na. If you write this in a notebook, will you get the result set? Will you get this output like this? If you write in a notebook, no. You are writing in a framework. And that frameworks are what? Databricks is one framework. Synapse Analytics is one framework. So when you are writing Python code in this framework, that we are calling it as PySpark. Okay. See, now I have restricted to 10 records. That's why it is giving me the output. It is giving me the output in the tabular format. So if you notice here in this analytics workspace, okay. So what is happening here? We are uploading the data. Okay. We are creating a Spark pool. We are writing the query as per our requirement, and we are seeing, or we are doing data visualization also. Okay, this is in the tabular format. If you want, you can see this in the chat format also. You can see this in the chat format also. This is in chat. Okay, this is in tabular format. Like this, we can do. Now, see, this is the complete. Is that clear, Rajesh? Okay, I'll give you one article, Rajesh. I'll give you one article. Okay, you can read it. Okay, it is clear. Okay, fine. So now, see, this is the result set. Suppose if I want to write some more queries, if I want to do some other visualizations also, so how I can generate the new cell? This is cell. This box is called as what? A cell. And this complete top to bottom, we call it as what? A notebook. We call it as a notebook. Now, if you want to generate a new cell body to write some other code, what we have to do here? See, to clear the result set or output. This is our result set. Na? This is our result set. We got some data, correct? First time it has taken how much time? 4 minutes 11 seconds it has taken. If you want to restrict to only 5 records, then it will you mention here 5. You will say here run. This time it will give you the result set very quickly within 1 minute. But in 3 seconds it has given you. See the performance here. See the performance here. How much fast it is. In just 3 seconds, it has given you the result set. See, 5 records we have got. 3, 4, 5. Last time 10 records we have got. Okay, fine. So now what I'll do, I'll clear this result set. How? What we can do here, see, to clear the result set or output, just click on clear cell output button. Clear cell output button on the top right as shown in image below. This one. You have to click on this button. Okay, this one. So you see here, this one. See, the result set got disappeared. The output got disappeared. Now I want to create a new cell now, right? So click here on this one. Okay, and then say here split cell. See, a new cell got generated. A new cell got generated. If you want to run particularly this cell code, then this is the run button. If you want to run particularly this cell code, then you have to click here on this run button. Okay, so what next it is saying here, see, okay, to see the schema and data type of our Parquet file. Okay, just paste the below code in the new cell and also change the link. Okay, like above in the code. So I just want to see the schema. See, if I open this Parquet file, I cannot view it. Okay, this Parquet file, I cannot view. If I see here, if I go to edit, see, it is not viewing. So if you want to see what data, what columns, what data types I'm having in this Parquet file from the New York City Tax Enterprise, then I can use this code here. Okay, I'll say PySpark as my magical command. Okay, and I'll remove this particular path. Okay, I'll keep this path same, this one only. Okay, and then I'll say here run cell. So what it is giving me the complete schema of my Parquet file. Okay, I'm having these many columns: date ID, okay, Medallion ID, Hackney license ID, okay, pickup time ID, these are blah blah, tax amount, tip amount, okay, if customers has given any tip, okay, what is the tax amount, like, if you have paid some uh, let us take $20 for an example, then in that $20 some amount will be the tax also. Same in India also, when we pay to Ola and Uber, okay, some amount will go to your as part of tax also, GST kind of stuff, whatever it is. So this is what it has given the complete okay, data, sorry, not data, the data type, the schema of my Parquet file, this file. Okay, this file. Okay, fine. Now to create a new cell in the same notebook, okay, or same window, click on the last line of the code, at the last position in the current cell, click on 3 dots extreme right, split cell. Everything is in written very clearly, guys, here. See, click on the last position of the, okay, cell, and then say, if you keep the cursor here, if you say here split cell, then this will come into your second cell. See, if you want to experience that also, see split cell. See, this came here. So this is not correct now. This is not correct, right? So that's why here I have mentioned everything. Click on the last line of the code at the last position in the current cell, then click on 3 dots extremes and split cell. Fine. This is one split cell. Loading New York City taxi data into Spark database. Now we'll create the database also. Okay. What we are doing here in this demo, we are creating a database with name as New York City taxi and loading the data into the trip. This is what NYC taxi is the database name and trip is the table name. Trip is a table we are creating inside this taxi database, New York City taxi database. And in this table, we are loading the data frame table also. Okay, virtual table. DF is what? Virtual table we have read above. Okay, after the new cell gets created, yeah, new cell is ready for us here. Okay, paste the below code in the cell body, and in below code, we are creating DB and table. We are creating DB with this name and table with this name, and then run the cell, publish all and publish. So see here what I'm doing, spark.sql, I'm converting to SQL, and it's very simple SQL query I'm writing, because my Spark framework will support. Okay, my framework will support a SQL queries also. That's why I'm saying here, create database if not exist. What database name? This database. And then create a table here inside this database. This is the database name dot table. I'm getting a table. So I'll just come here. I will paste this code, and then I'll just say here publish all, publish, and I'll run my code. Okay, I'll run my cell body. So what will happen with this? It will create a database and a table. Create again a new cell and paste the below code and run the cell. And here we are retrieving the data from our trip table and assigning to this virtual table, DF. Okay, which is our virtual table, and displaying the result set with display method, publish all and publish. Then run here. We are going to see here the database created and trip table also got created. 8 seconds is been done. Just hold on. So what we are doing, we are converting. Okay, to SQL using the dot SQL method, and then we are writing the SQL script here. Okay, just hold on. See here what we are doing. We are simply writing a select statement. Select star from database name dot table name, and we are assigning whatever the value to this df1 virtual table, and then finally we are saying display df1 here. Okay, okay, so it got created. Okay, the database got created here. Okay, then next what I'll do, whether it is created or not, that also I can check it here by passing in my query. Okay, so I will create a new cell. Okay, split cell. I will write the code here and I will run. If I get the data, then it means my database and table also got created here. Super. See, complete records, how much fast it has given you the result set. So from where we are fetching the data? We are fetching the data from this database, from this table. And this database, this table, we have created here in the above query. Okay. Getting, I see all the data you have got it. See, my God, how many records are there? Plenty. If you want to restrict some records, if you want to see in the form of a chart and all, you can customize your SQL query. SQL is simple as compared to Python scripting. SQL is easy. So see, this is what we are doing. Now we are customizing the query. Select passenger count, sum of trip distance, average from this table, from this database, from this table, where trip distance should be greater than 0 and passenger count should be greater than 0, group by passenger count and order by passenger count. Because why we are using group by here? Because we are using the aggregate functions. So when we use aggregate functions, then definitely after where clause we have to use group by. Okay, for the columns, definitely this is the basic SQL queries, guys. Basic SQL queries knowledge. Okay, so then display df1 is the virtual table. Okay, we are assigning the complete after this all these calculations, whatever the result set we'll get, that result set we are assigning to, we are assigning it to df1, and then we are using display method for df1 dot write save dot tables in. What we are doing now, we are saving this data, this result set, into another table that is called passenger counts stats. Passenger counts stats, we are saving the result set whatever it is into this table. Okay, fine. That's why we are saying here, see df1 dot, this is virtual table in which we have assigned the complete value. This complete value we have assigned it to this df1, then display method, display output, and also we are saving this into this table by using this method, save as table. Okay, I'll just take this code. Okay, and just clear the result set. I'll click on the last position here. I'll say here split cell, execute, put the script here and run the cell. run this cell. Okay, fine. So with display method, data is getting populated. Also, data got saved into this table, passenger counts stats. If you come here now, this time what we are doing, we are checking with the select statement, and in this select statement, we are fetching the data from passenger count stats table. Okay, so from trip table to passenger count stats table, we have saved the data. So I'll just come here. Okay, let me check. Okay, I'll just put into the last position my cursor. I'll say split cell. I'll paste it here, and I will run this query. I should get the output now from this table. Aha, super. See, I got the output. I got the output here from this passenger count stats table. That is what I'm showing. Hence, like above, we are using Spark pools and writing the PySpark commands to create the database tables to retrieve the data from Parquet files and store it in PySpark database. Okay, what is our PySpark database? PySpark database is this one, New York City taxi. And then we have created first trip table, and then we also created one passenger count stats table also. Okay, so that is what I'm trying to say here. Okay, so like this, we can create the database tables to retrieve the data from Parquet file and store it in PySpark database and tables in Azure Synapse Analytics workspace. In Azure Synapse Analytics workspace. Okay, guys. So this is how it is going to be. Okay, fine. If you see here, when we have done this one, then you are going to see in the managed resource group, one resource group will also get created. Yeah, see, Azure Synapse Analytics managed resource group. Here, if you see, we are finding here multiple SQL Server instance and SQL database, SQL database and SQL Server instance. Okay, this got created along with our Synapse workspace. And if you come here to workspace, here you are going to see the Spark pool. Yeah, go to manage. Yeah, this is the one which has run our queries. Which has run our queries. How can we say it has run our queries? Because here, when we have used this one, see, we have selected to Spark 1. We have connected to, attached to Spark 1. That's why this particular, okay, this particular Spark pool has run our queries. Just say here, duplicate tab. If I come to manage here, this one, Spark 1. This one, Spark 1. Yesterday we have done dedicated SQL pool. Today we have done with the Apache Spark pool with the notebooks. Okay, this is the notebook, and we have written multiple coding here to get the data from our New York City Taxi Enterprise company. Okay, fine, guys. See, guys, this topic is very new, very new. Okay, I completely understand. It will take some time. Okay, just in 1 hour, you are not going to understand 100%. Please give some time to yourself. Don't be panic. Read it multiple times, and also make some Google search, okay, or YouTube search from your end as well. Okay, maybe Rajesh. Okay, so you want about Apache Spark, right? Okay, just hold on. Lot of frameworks are there, guys. Lot of frameworks are there. I'm telling you now, until 5 years of experience, also you'll keep learning the things. You keep learning the things. The learning is never going to end for you. Please remember this. Okay. See, it's a multi-language engine for executing data engineering, data science, and machine learning on single node machines or clusters. Okay, it's a multi-language engine, Apache Spark. Okay, that's it. That is what they have given. Not much information. The website is very good, but no much information. We are having it here. Sorry, guys. Here we are having good content. See, Apache Spark is an open source analytics engine used for big data workloads. Okay, it's an engine or a framework, whatever you want, you can say, for big data workloads. It can handle both batches as well as real-time analytics and data processing workloads. Apache Spark started in 2009 as a research project at the University of California. Okay, researchers were looking for a way to speed up the processing jobs in Hadoop systems. It is based on Hadoop MapReduce and it extends the MapReduce model to efficiently use it for more types of computations. Okay, this is giving very good knowledge. Okay, so Rajesh, please take this one. Okay, see guys, if you search it in Google, you will get Rajesh. Did you get the link? So Rajesh is not in the meeting. He has already left the class. Rajesh, you there? Then why it is saying me you are not in the meeting? Okay, I'll do one thing. 1 minute, 1 minute. I think there is some problem in the Zoom. It is saying me that you are not in a meeting. Okay, Rajesh, did you get the link? No, I kept it for all. Okay, okay, all right. Fine, guys. So what I'll do, I'll just stop the class here for today. What is Azure Stream Analytics? Okay, Synapse Analytics is what we have seen, and we'll see in tomorrow's class what is Stream Analytics. What is Stream Analytics? We'll see in tomorrow's class. Okay, hopefully we'll complete this in tomorrow's class. So maybe I can say here this one, and then I'm going to explain you a project. Okay, I'm having one complete end-to-end project for data engineering. I'll explain you that complete project. Okay, you can do that project. Okay, in that project, what all the tools we have learned. Okay, that project I have designed. Okay, on top of those tools only, like Databricks and Azure Data Factory, Synapse Analytics, and Data Lake Gen 2 storage account, SQL Server, and all. So, what all the tools we have discussed in our course, and I have designed the project considering all those tools only. That project is completely different. I'll explain, no worries. So, hopefully by Monday or Tuesday, we are having our last class, guys. Monday or Tuesday, we're having our last class. I'm going to give you some assignments also, and all the softwares, all the materials, all the things. Again, I'm going to give end to end completely in the last class. Interview question and answer, certification terms. Okay, sample resumes I have shared with some people already. That all I'll share. Okay, hopefully either on Monday or Tuesday. So our last class would be on Monday or Tuesday. We'll see how it goes. All right, guys, is that clear? People started already leaving the class. Fine. So I'm good to close the class, guys. Yes, no? Okay. All right. All right. Thank you, Rajesh. Thank you, everyone, guys. Bye bye. Take care.